Hello. Nice to see so many of you here. So, for those of you who don't know, my talk today is going to be on time, and it's mainly from the point of special relativity. So, does anyone know anything about special relativity? Yes. Well, not to worry. I'm going to tell you. So, let's start with time. Out of interest, who here has actually thought about what time is? Could you just roughly give us your own perception of what time is?
I honestly got a headache from thinking about it.
Yeah,
so
it's hard, and theoretical physicists to this day still argue and write many papers on what they think time is. But in 1905, Einstein came to some interesting conclusions, and I'll talk about that. So time, you can't see it, you can't weigh it, but we experience it every day, every second, unit of time. But we don't really understand it. Is time the same for everyone? To understand this, we must take a journey back in time to 1905, to a young Swiss patent clerk named Albert Einstein. So there's a lot of contrary to how people think Einstein first came up with this. One of the most famous ideas is that he was sitting on a tram, and he was looking, so from where you are to me right now, say you're a clock tower, and I'm a tram. Okay, I'm Einstein on a tram, and I'm moving away from you, and he was looking at the clock, and he was thinking, does time, is it passing the same even though I'm moving away from it? And because I'm moving, is it the same? Am I experiencing it the same because I'm moving? And am I experiencing it the same as people who are not moving? This isn't true. That didn't happen. It might have, but it's not how Einstein came up with it. Einstein was a real pioneer and a lover of something called the thought experiment, which, how he does them, I have no idea, because it's Einstein. But he was sitting at his desk in his patent office, obviously not doing his work because he didn't really enjoy that. He spent all his time sort of doing physics papers and reading things about physics. Love physics and maths, not so much maths actually. But he thought about a train. He thought about a train stop, and there's a train going by, and on the train stop there's what I'll call an observer. And from classical mechanics, Einstein knew about reference frames. Now I'm just going to pause right now and talk about reference frames really quickly. So a reference frame, we're going to talk about inertial reference frames, which deals with special relativity. Which, in fact, special relativity says there are only inertial reference frames. So a reference frame is, say we're all one person right now, okay? And we're looking outside the window, and there's someone standing, he's moving, right? And we're standing still. We observe him from our reference frame, and vice versa. He has his own reference frame of him looking at us whilst he's in motion and we're stationary. But to him, are we stationary or is he stationary? It's complicated to understand, but it's all about relative motion. That's where relativity comes in. So he thought, if there's a strike of lightning, so two strikes of lightning, and there's a man on the platform, and there's a man in the train. The train's going by at a high speed, and the speed of lightning, so the lightning bolts go here and here, and the man is here, and the train's going by. He thought, who will see the lightning bolt first? The first one, or the second one? Right, person one, person two, should have clarified that, a bit nervous. So the two lightning strikes at the same time, right? But what he found is the person who's moving will experience the lower one first because he's in motion. And we can prove this. He realized that because of the time difference, but right, we're lost. Right, we'll stop because that's going nowhere. Right. Hello.
Hello.
That's where we're stopping here.
Hello.
Is right. Time passes slower for people who are in motion, right? Learn that. That's really important. So, yeah, go for it.
Staying young.
What I have here is a really simple diagram. One of my main aims is to teach you, even biologists, that you can do special relativity because it's that easy. So, what we have here is called a photon clock. Okay. This is stationary. So what this is two mirrors, and the ball there is a photon, and the arrows indicate its motion. So for simplicity's sake, let's say time it takes for a photon to go up and then down is 1 second. So that's mathematically we'll put it like that. And now if we put it on wheels and put it in motion, what you'll find is, and graph it out, the motion of the photon is like that. And if you do Pythagoras, and that's the hardest maths of special relativity, I've done that here, that's laying out the symbols there for people who like maths. And then simplify that with special relativity, you get this formula here, which is called a Lorentzian time dilation formula. And Konrad Lorenz was a really helpful person to Einstein because he did a lot of stuff on time dilation. And Einstein realized that if he did this formula with imagine the photon clock in his thought experiment, then he can find the factor at which the time difference for different observers. And that is called gamma. And that is this. And if you times that by the original time, so let's say proper time is someone who's in the stationary reference frame, then you find the difference in the time dilation. So I thought really long and hard how to. We usually do topics where people can discuss. I thought time is kind of like it's ambiguous, but I thought I would leave with a challenge question. And some of you might have heard of this before. It's called twin paradox. Twin paradox? No. Okay. Well, hard for you, I guess. So bearing in mind from what I've said, people who are in motion experience time slower, as proven by the photon in motion here. So let's say we're in a really advanced civilization and we've developed light speed travel, so we can travel at the speed of light. Okay.
I think I have heard this before.
So there's two twins. One's on Earth and one is really adventurous and goes on a space mission. And he goes out at the speed of light and for X amount of years. Let's say 70s. The amount of years, it doesn't really matter as long as it's a long time. Twins, same age. One's on Earth. One's traveling at the speed of light. He goes all the way on his journey. And he comes back. Are they the same age still? Is one younger? In which case, which is younger and which one's older? If that's the case, discuss.